while I do this is wreaking havoc on my number of steps every day because I'm no longer walking all over the room. I'm confined here. But anyway, okay. So we're going to do the last problem in section 5.6. And then, as I said, I have some problems I want you to do on your own with a partner. Okay, and we'll set that up. So let's start with page 257, number 25. And the test, or the quiz on 5.4 to 5.6 is on Wednesday. Okay, and I believe that the homework is due tomorrow. All right. So Gianni, I think you won the race and you found the page first, so why don't you read the problem for us, please? All right, so wow, okay, that's kind of weird. And it's kind of hard to understand. So let's start by drawing a picture. So I've got my X and Y axes. They tell me that my particle is moving along a specific kind of curve. What is that? A parabola. Okay, so I know it's going to look like that. So here's going to be y equals x squared. And then I'm talking about a line that joins wherever the particle is and the origin, right? And that line makes an angle of theta with the x-axis. And it's how that angle changes that I want to find, right? Okay, so what's the symbol for the thing I want to find? Not d theta dx, because remember these are related rates and everything's moving. We want to measure everything with respect to what? dt, time. Okay, so I want to find d theta dt, but I should probably write down as well the stuff that I know, because there were a bunch of numbers that I was given in the problem. So what's something that I know? Okay, so I know I'm talking about where x is equal to 3. Okay. Is there anything else I know? Okay, but let's see if we can kind of, there's an implied thing that I know. If x is equal to 3, do I know what y is? What's y, Sari? 9, right? Because I know that y equals x squared. Okay. So my next step in solving problems like this is usually to find the equation that relates the thing that I'm looking for and the thing that I know so that I can take its derivative. So how are theta and x going to be related here? Well, x cosine theta isn't enough. You're on the right, you have the right idea, but cosine theta would be x over something, right? X over the hypotenuse, which sounds a little complicated. Is there a simpler way that I can relate theta and x? Yeah. But I want to have theta in my equation because I want to have a d theta dt. So using cosine was the right idea. It wasn't perfect, but it was the right idea. It just wasn't the right trig function. Tangent. What's tangent theta going to be equal to? Y over x. Okay. So this is good because I've related my theta to my x. We've got that y in there, but we might be able to do something about that. Okay, so I'm not going to worry about that yet because I do in fact have a relationship between y and x. Yes, I do know that at this moment y is equal to 9, but you have to be very careful when you do these problems not to substitute the numbers in too soon because that locks you into one particular point instead of developing an equation for how the rates are related. Okay, that'll work anywhere. So the next step is usually to take the derivative. So what's the derivative of tangent theta? It's not negative. I think it's just secant squared theta times what? Am I done? What's theta a function of? Time. So what do I have to multiply this by? D theta dt. Okay. Remember, when we're doing these related rate problems, it's really like applying the chain rule one more time because everything is a function of t. So I always have to take that derivative with respect to t. Now I need to take that derivative of y over x. So what am I going to have to use? Quotient rule, which we haven't practiced in a while. So let's do that. Okay. All together now. If I do the quotient rule, well, tell me in words what the quotient rule is. Times u prime. You got it. Okay, Casey had it for us. So what's v in this problem? X. What's u prime going to be? Dy dt minus good Sarah, all over x squared. Okay. So now I have some issues. I don't know what secant squared theta is. And I don't know what dy dt is. Anybody have any ideas how I can solve those problems? Let's start with the dy dt problem. We're not plugging in yet. Are y and x independent of each other? No. How are they related, Maggie? Y equals x squared, right? That was my original equation for the path that my particle is taking. So can I find dy dt? How do I find dy dt? Take the derivative of both sides. So I'm going to get dy dt is equal to what? Times dx dt. Okay, so that's cool. That's one part down. Well, I'll wait till everybody writes that down. Side trip 2, we have to find secant squared theta. Anybody have any ideas? Somehow. Well, let's hang on a minute. Zoe, you are on the perfect track. Okay. What does secant theta really mean? 1/cosine, right? And I have this triangle, right, where here's theta, here's x, here's y. What's the hypotenuse going to be? Thank you. Okay, so what's cosine theta going to be in terms of my triangle here? Not y. Princess Sakatoa. Okay, so this is going to be x over the square root of x squared plus y squared. Everybody with me? Sarah, are you with me? Okay, so cosine theta is adjacent over hypotenuse. It's all got to be in the denominator. Okay. And then a denominator of a denominator is a numerator. So this is going to become x squared plus y squared over x. It's all right? With me? Okay. I need a new page here. All right, so we had that secant squared theta d theta dt was equal to x dy dt minus y dx dt all over x squared. Okay. And what I'm going to do is I'm going to divide both sides by secant squared theta. Okay, so that I can get my d theta dt by itself. Fair enough? Okay, so d theta dt is going to be x dy dt minus y dx dt all over x squared secant squared theta. Well, we're going to plug in what we have for secant squared theta and dy dt first. Okay. So d theta dt is going to give me x. dy dt is 2x dx dt minus y dx dt. all over x squared times, what was my cosine theta? X, oh, what was it? What was my secant theta? Sorry. Over x, that whole thing squared, right? I did it a little differently in my notes. That's what's messing me up here. Okay. And now, well, we could do some algebra, okay? Because what's y after all? X squared, right? So d theta dt, so if we combine here, that's going to give us 2x squared dx dt. Y is going to be equal to what, Priya? X squared and dx dt. So then my denominator is x squared. I'm going to evaluate that squared. So that's going to give me x squared plus y squared in the numerator. Hang on a minute. All over x squared, right? Because I have to square what's inside the parentheses. Yes, it will be. Hang on, Priya. For those who will be watching from home, we want to make sure we don't skip an algebra step. Little bit, yes. So in the numerator, I'm going to combine those, and that's going to give me x squared dx dt. In the denominator, I believe I can cancel those. Am I right? Are you doing the algebra yourself? Okay, so that's going to give us x squared, and then when we substitute in for the y, we get x to the fourth. Correct? Because it's y squared, but y is equal to x squared, and x squared squared is x to the fourth. You with me? Okay. And then I can get rid of an x squared out of the whole thing, which gives me dx dt over 1 plus x squared. You know me, I love a good algebra problem. All right. We probably could have substituted the numbers in farther back, but honestly, this was more fun. Okay. So what's dx dt? 10 meters per second. And then I've got 1 plus, and what's x? 3 meters squared. So when we do that, do not get out your calculator. What do we get? 1 what? Not agree. Radian per second. Remember, as wacky and weird as it is, that radians aren't a real unit. And we'll talk about this in AP Physics where it's a little more important. But radians are not a real unit. Radians are a placeholder. Radians say, hey, remember, this is an angle. But you don't have to cancel radians, and I can pluck them out of empty space and write them down on a problem if I want. Okay? Radians are weird. They're kind of the ghost unit of, I don't know, calculus. Okay? So we good? It was a pretty complicated problem, I thought, when you first read it, and we made it through. And we probably could have substituted a whole bunch of stuff in here. Okay, we probably could have taken this line and just put in 3s and 9s and 10s and we would have gotten the same answer, but we would not have had as much fun, in my opinion. Okay, so just for those who are going to be playing from home, these are the problems that we're going to work on with a partner. And then I'm going to turn off the recording. So page 261, number 36, page 263, number 60, and page 262, number 45, okay, which are all related rate problems, but actually they're not all related rate problems, but I think they encompass 3 important types of problems that you're going to encounter in the quiz on Wednesday. I would not say that these are the only problems you will encounter on the quiz on Wednesday, and I have to say that I picked those problems without having looked at the quiz from Wednesday, so there are no hint, hint, clue, clues here. It's just these are all things when I was looking through those pages that I know you need to know how to do. Okay, so I'll set up pairs in just a minute. Let's see.